This diagram should look familiar to you. It is the diagram that's on the back of the periodic table showing the 4 units that are equal to each other. The base unit in counting for chemistry is the mole, so that is in the middle of our triangle. 1 mole is equal to, if you go up, 22.4 liters of gas at standard temperature and pressure. If you go to the left, it is equal to the molar mass, which must be calculated for any element or compound using the periodic table, and make sure they are all to 1 decimal place. And it's also equal to 6.02 times 10 to the 23rd representative particles, depending if it's an atom, a molecule, or a formula unit for an ionic compound. So let's get to the questions. The first problem says, what is the mass in grams of 1.48 times 10 to the 22nd atoms of iron? Now you'll notice every problem is set up using the half times 1 over half equals W. So I start with my 1.48 times 10 to the 22nd atoms. Now I'm allowed to use any of the 4 things that are on the bottom that will allow me to transfer from one unit to another. Well, atoms is Avogadro's number, so I'm going to put that in the denominator so the atoms cancel. Now I want grams, so I need molar mass. So I look on the periodic table to 1 decimal place. Iron is 55.8 grams. So now I do my math. I do 1.48 times 10 to the 22nd times 55.8 divided by 6.02 times 10 to the 23rd, and it comes out to 1.37 grams of iron. The second problem, the main problem was it did not give the formula for potassium oxide. So the first thing you had to do when you want to figure out how many moles are in 43.0 grams of potassium oxide is you had to get the formula as K2O. Once you have the formula proper as K2O, then you use the molar mass in the denominator with 2 potassiums and 1 oxygen to 1 decimal place is 94.2 grams. Now on the top, I want moles, so the only thing I can do with moles is 1 mole. So my math is 43.0 times 1 divided by 94.2, which comes out to 0.456 moles of potassium oxide. The third problem, how many moles are in 122 grams of PbOH4, which is lead 4 hydroxide? So the first thing I have to do is get the molar mass. It's 1 lead plus 4 oxygens plus 4 hydrogens when added properly will give me 275.2 grams of potassium 4 hydroxide. Now I want moles, so down below you see you used 1 mole for that. The math is 122 times 1 divided by 275.2, which gives me 0.443 moles of lead 4 hydroxide. Now you'll notice all 3 of these start with 3 significant digits, so they end with 3 significant digits. All right, the next problem. How many grams are in 0.120 moles of hydrobromic acid? I did not give the formula for hydrobromic acid, so you had to figure it out as HBr. Now, this time I want grams, so I'm going to put molar mass on the top, and I have moles, so I'm going to put 1 mole of HBr in my denominator. My numerator has to be the molar mass, which is H plus Br, which is 80.9 grams. Now I do the math, 0.120 times 80.9 divided by 1 gives me 9.71 grams of hydrobromic acid. The next one, how many formula units are in 2.86 grams of Na2S? So I give you the formula of Na2S, I have grams, so I need to calculate the molar mass. That's 2 sodiums, 1 sulfur, which comes out to a total of 78.1 grams. Now this time I want representative particles, so I'm going to use Avogadro's number. And when I do the math, 2.86 times 6.02 times 10 to the 23rd divided by 78.1, 2.20 times 10 to the 22nd formula units of sodium sulfide. And the last problem, how many liters of diphosphorus pentoxide exist at STP if you have 10.0 moles of P2O5? So I have moles, so I'm going to put 1 mole in the denominator. I want liters, so we finally get to use the 22.4 liters. And 10 times 22.4 is 224 liters. Even though the formula was not given for diphosphorus pentoxide, you didn't really need it because we didn't have grams, so we didn't need to worry about its molar mass. Thank you.